This assessment asks us to draw an arrow pushing mechanism for the first step of 3 different reactions from a figure in the text. We'll do it for the one on screen. I'm going to redraw so we don't have to worry about the Weatherman effect, but the reaction is going to start by the alkene attacking the electrophilic mercury. When that happens, we're going to kick out the good leaving group of acetate, but at the same time, we know that the mercury has d electrons that it can donate back to this carbon here. As these pi electrons here are moving out to attack the mercury, we're developing a partial positive charge that gets attacked immediately. Now, this is a planar alkene, so the question asks us to also justify the stereochemical outcome. As a planar alkene, approach can happen from the front or the back. We're going to show the mercury adding to the back only of the alkene. In real life, it's going to happen on both sides, so we will end up with a racemic mixture. You can see that indicated here with the plus minus. But let's show the mercurinium ion forming on the bottom. When that mercurinium ion forms on the bottom, the methyl group is of course going to be coming forward. Now, in the next step, a molecule of water is going to attack the electrophilic mercurinium ion at the most substituted carbon. So water, these electrons on oxygen, are going to be added to this carbon, pushing these carbon-mercury electrons back onto the mercury. Because the mercury is on the bottom, that water is going to add on the opposite side. So it will be on top, as we can see in our product where we have it shown as a wedged bond. Right? So water has added to the top. When it adds, it's bringing along its proton. And so we can draw that here. Another thing to note before we talk about what happens to that proton is the fact that this methyl group, notice it was bold and wedged, it was coming towards you. Because water has added to the top, it's actually pushed that methyl group down, so now the methyl group is actually going away from you. To finish the reaction, water can come in, another molecule of water can come in and remove that proton in an acid-base reaction to complete the formation of the alcohol. Now, if we were in the lab, we would take this molecule and add sodium borohydride in a second step, but that's not the topic of this assessment, where all we needed to do was show the mechanism of the reaction up here. And we've accounted for the stereochemical outcome by acknowledging that if the mercurinium forms on the bottom, water will add from the top. If the mercurinium had formed on the top, water would add from the bottom. Both of those things are going to happen in solution, and so we get a racemic mixture. But in every molecule, the hydroxyl group and the mercury are on opposite sides.